drawing of those documents, we're going to have a look at how all of those different areas interact with one another. As I said before, my name is Adrian Conard, and I am a Senior Applications Engineer here at INTERCAD. So what you should be able to see on my screen now is the Resolute bolter. So this is a vehicle designed for use in underground mines. It's designed to drill holes in rock and then apply mesh to, and then affix that mesh to the ceilings to prevent rock falls or to limit rock falls. The area that we're going to be focusing on today is this boom area that you can see highlighted in blue. So I'm just going to open up that particular area so we can focus on it. And what you'll see is that although it's able to move around, we can see that currently there's nothing attaching these hydraulic cylinders to the rest of the area here. So we're going to be designing a component to fit into that area. We're then going to be detailing up that component in a 2D drawing. And then finally we're going to we'll bring that component into an assembly with other components and then detail up a drawing of that assembly. So to begin with, I'm going to create a brand new part. A part is a document that details up an individual item. Now, before we go much further, I'd just like to get a bit of an idea of what experience people have had with CAD and 3D CAD in particular. So I'm just going to launch a poll, just asking what drafting tools you are using currently. So that's going to pop up on the screen. Okay, so I'm just going to pop that up on the screen so you can see that as well. And so you can see that over half of you have got some experience with some other 3D CAD and some 2D CAD as well. A few of you have had some experience with SolidWorks and also manual drafting and sketching, and at least one person there hasn't had any experience with CAD at all at the moment. So we've got a nice sort of mix there. So some of the terms that you see me using are going to be specific to SolidWorks or 3D CAD, but hopefully what we're going to be looking at today is going to be applicable to most of you. Okay, so what we're going to do now is start to create our first 3D part. Now, although we are going to be designing in 3D, a lot of what we're going to be doing is actually going to be sketching in 2D. So your 2D skills don't get thrown away when you use your, or when we start to use 3D CAD. So I'm just going to be drawing up a couple of concentric circles here. You notice as I draw them, I'm able to dimension these items as I go. Now, unlike a traditional 2D CAD package where you would draw up your circle to a particular size and then apply a particular dimension, in SolidWorks, in a parametric CAD system like SolidWorks, the dimensions actually drive the sketches. So if I want to change this particular dimension here from, say, 130 to 120, it changes the size of that circle. So the dimensions are actually driving the sketch rather than the sketch driving the dimensions. All right, I'm going to close that sketch now, and we're going to use this to create our first 3D part. So I'm going to stretch this sketch now up into 3D space. Yeah, we can sketch it in one direction or the other just by how we drag it. I'm also able to cause it to stretch in both directions evenly, which is what we're going to do here. Now, I can either drag it freehand like I am here, or I can snap it to these graduations that we see on the ruler here. So I'm going to drag this out to say 125. So we've now got our cylinder 125 mil high to those particular dimensions. I can also play around with the dimensions, as you saw there, just by dragging the handles on those. All right, the next feature that I'm going to create is going to be another cylinder in the 90 degrees to this cylinder here. So I'm going to start another sketch on this plane here, and this time I'm not going to dimension up my circles, so I'm just going to rough them out like so, and I'm going to use another tool that I have available to me called Fully Defined Sketch. So when I run that, it automatically dimensions and applies any of these relations, such as the fact that this point is horizontal to this point, in order to fully define and locate everything inside my sketch. I can then just change these dimensions to meet my requirements. Like so. And now I'm going to extrude this one out as well. Again, even after we've created our features, we can come back in and play around with our dimensions. So if I don't want that to be 160, I want it to be 150, I can change that dimension and it will update on the fly. All right, so we've got these two mounting points, and what I'd like to do is join them together. So I'm going to start another sketch now. It's going to be used to join together these two components. The first thing I'm going to do is create a couple of center lines that I'm going to reference later on. We can use these for mirroring and construction purposes. All right, next I'm going to draw a rectangle. So starting from the center here, I want it to be, say, 70 high. And I want the outside to align with the silhouette edge of this cylinder here. Now, I get feedback from SolidWorks letting me know whether or not a particular entity has been fully located or fully defined. You can see all of these sketch entities here are in black, whereas this entity here is in blue. That's SolidWorks telling me about the status of the particular sketch entity. So this sketch entity is still able to move around, whereas this one here is not. All right, I'm going to continue to draw on this sketch here to join these two parts together. The next thing that I want to do is to copy the outside edge that we see here onto the current sketch. So if I click this outside edge here, I have a tool that allows me to copy that to the current sketch plane, which you can see there. It's copy that edge down onto the current sketch plane. Next up, I'm going to draw a line from here, and we're going to bring it up to here. But actually, I've decided that I want to mirror all of these entities. So before I start that sketch, I'm going to select this center line here and turn on my dynamic mirroring. So now any entity that I draw on this side here is going to be mirrored on the other side. So as I draw this out, you can see it's being mirrored on the other side. As I'm drafting here, I can call up things like the fact that I want this line to be horizontal, or I want this line to be parallel to the previous line that I drew. So I can automatically make that line parallel. Now I'll bring this down to this line here, and it joins it back up again. I'm finished with my mirroring, so I can turn my dynamic mirroring off. Now, as I move these sketch entities around, they still stay mirrored. So it maintains that relationship between the lines. So all I need to do now is to dimension these entities. and we'll set an angle. Notice I can use the exact same tool to dimension angles as I can to dimension these lines here. All right, I'm finished with that sketch now. So what I want to do now is to use that sketch to create the joining piece between the two pieces that I've got here. So I'm going to pick up, so I'm going to start my extrusion. We'll pick the sketch that we want to use. And what we're able to do is select the contours, so the areas that I want to extrude out. So if I can select that area now, and you can see a nice little preview. I can say, okay, I want that to be 120, but I want to apply it evenly about the sketch plane. Pick, and there's the result. So we've joined those two parts together. I'm going to come back now and reuse that sketch that I created before. Excuse me. And I'm going to use this rectangle here to cut away the material that I've got in here. So I'm going to create an extruded cut. I'll pick this area here, and I'm going to set my end conditions to be through all in both directions. So no matter how big or small this part ever gets, it's going to cut completely through the part. We've now cut that material away. Now it's looking good, but I've got these sort of leftover areas in here. Now I could come back and create another sketch and do a cut to cut completely through this part. But I've got another little trick up my sleeve. What I'm actually able to do is to delete these faces, and it's going to patch the remaining area around it to keep it smooth. So if I right-click on this face here, I've got an option to delete it. I'll pick all the faces that I want to delete. I want to delete and patch them. And it's removed those faces. That's looking pretty good. All right. So we're almost finished with this part now. What we need to do next is to detail this part up. So I'm going to take this part as a 3D part, we're going to save it, and then I'm going to insert it into a drawing. So save this part. And I'm now going to create a drawing from this 3D part. So it brings up our title block, and what it gives us over on the side here is our what we call view palette. So it's showing me all of the standard views that I have to the part. We can drag each of these parts in to or into the drawing to be able to show each of the 2D views. So I'm going to bring in, let's say, the front view, and from here we can project our views. Maybe I even want to grab an isometric view as well, and I'll pop that down like so. I don't need the center lines in this view. Also, let's say I want to make it a shaded view as well. Okay, so this is looking pretty good so far. What I do want to do next, though, is bring in my dimensions that I created in the part itself. I don't want to have to recreate all of the dimensions that I've created in there. So what I'm going to do is go across to my annotation tab here and to model items. And we're going to import from the entire model into all my views. I'm going to bring all of the dimensions that we've created in that particular part. And it brings all of those dimensions in from the part. So we don't need to create the dimensions all over again. We're able to import those dimensions from the part itself. These dimensions are bidirectional too. If I make a change to a dimension here, it will drive back into the assembly. So, speaking of that, I'm now going to create an assembly from our part. So I'm going to go back to my mounting part here, and we're going to create an assembly. So make assembly from part. I want to bring this particular part in. And so this becomes the base part for our assembly. All right. So what we want to do now is to bring in some of our other components that we've got inside the assembly there. And the first thing that I want to look for is an expander pin. So I've got a search there that I'm able to search, look through all of my documents on my computer till I can find the component that I'm looking for. So here's my expander pin, and I'm going to drag that and bring it in. Now notice as I hover over the hole here, it's automatically locating this component. I'll drop that down there. Now we've got two different sizes of this particular component. We've got the 150 mil long and we've got the 220. I'm going to drop the 220 down and locate it. There's a few other components that we want to bring into this assembly as well, so I'm just going to drag this down here for the minute. The next thing that I want to look for is a wear plate. Sorry, not a wear plate. What I'm actually looking for here is going to be, in our library, I've got a bearing. So what I'm going to do is drag that bearing from my library into the component here. And again, notice it snaps onto the component there. And I'll come around to the bottom and I'll pop another one into the bottom. They're the only two that I need. Now, these two components, these bronze bearings, are what we call smart components. These smart components have features that we can drive back into our part. So by selecting it here, I can insert my smart features. I'll do that for both of them. And if I take a section through my assembly, we can see what it's actually done. It's cut away the material in this other part here. So it's cut away the material, added a chamfer at the top and a fillet at the bottom there to accept this particular component. And in fact, if I go back to my part, we'll see that it's actually driven those features back into this part here. So we've been able to take features and embed them into those bushings so that when we bring them into an assembly, we can take those features and drive them into other parts inside the assembly. While I'm here, there's another feature that I would like to add to this component here. I want to add a grease fitting port. So I'm going to drag and drop this onto this face here. We've got different sizes of grease fitting port. So I'm going to select the correct size. It's now asking for this face here. We can then pick a dimension from the top and an angle, and that will help to locate our grease fitting port. Now, when I switch back to my assembly, those features have been updated in the assembly as well. So any changes that you make to the part will be reflected in every assembly where that particular component is being used. Excuse me. Okay, so now that I've got the flange in there, I would like to center this expander pin in here with respect to the rest of the components. Now, I could get out my calculator, work out what the distance is, and then apply a distance dimension between these two faces here. But I don't want to have to go through all of that. Instead, I'm going to create a relationship between these components called a mate relationship. It's a special relationship called width. And what that does is automatically centers two faces with respect to two other faces. So now, no matter how big or small this pin gets, and no matter how big or small the mount gets here, they're always going to stay centered with respect to one another. Well, that's looking pretty good there. So what I'm going to do now is grab the expander pin again. I want another copy of it. So I'm going to drag this expander pin and drop it onto this face here instead. So that is now centered into there. And again, I'm going to apply a width mate. So that's centered. But the problem is now this is far too long. So I'd like to use that other size that I had there, the smaller size. So I'm going to use the sub-assembly properties here to change it from the 220mm long configuration to the 150mm configuration. So that's definitely a better size. There's a few more components that I want to apply here. I want to look for my wear plate, so I'm going to drag and drop one wear plate onto here, and I want another one onto the bottom. And the last component that I want here from my library is going to be this grease fitting port. So just pop that into there. And we've now got all of the components necessary for the assembly. So again, I'm going to save this the component here. Okay, one thing that I'd like to do before I create a drawing of this assembly is that I would like to create an exploded view. This is really handy when detailing assemblies. It allows us to explode out the assembly so that we can see all of the different stacked components in our assembly. So to do that, I'm going to switch back to my assembly tab here, and we're going to create a new exploded view. Creating an exploded view is as simple as selecting the components that you want to explode, as I've done there, and then we get this little triad here with the three orthogonal directions. I grab that and I drag it out, and it automatically spaces those components out for me. I'll do the same thing on this side. Okay, so now with this one here, I have the ability to reuse its explode. So this sub-assembly that I inserted, this expander pin, already had an exploded view in it. So rather than have to recreate it again in this assembly, I've been able to reuse its exploded view already. So I've got a few more components to explode out. That one, drag it up, click on this one, drag it up, do the same to the components at the bottom. And now finally, we've got the grease nipple here. Now the issue that I've got with the grease nipple is I don't really want to expand it in one of these 3 orthogonal directions. So instead, I'm able to grab a hold of the center here and drag it over any cylindrical or conical face and realign it. So now when I drag this out, it's going to explode out in a direction that makes sense. That's looking pretty good. Now typically when you have exploded views like this, you'll have lines showing how all of those components come together. So we're able to create what we call an explode line sketch to do just that. So I'm going to pick on my explode line sketch. We'll pick one component. We want to run a line all the way down to this component here. Hit the tick, and it adds that line in there for me. I'll do another one through here, out to here. And then finally, I'll do one from here, out to here. That's looking pretty good. I reckon I'm just about ready to create my drawing. So I'm going to save this. And again, we'll use our Make Drawing option. I'm going to drag some views in. I'll grab my current view. This is looking pretty small, so I reckon I might change the scale to something like 1:4 or 1:5. Let's see what looks good. Yeah, that looks a bit better. But I want to show this in the exploded state. So I'm going to select this view now and show it exploded. Let's pop a couple of other views in here as well. Again, using this view palette to make it nice and easy. We'll grab a front view and a top view. That looks pretty good. I'll show this one shaded. Now, next, I need a bill of materials so that I can show exactly what this assembly is made up of. So to do that, I'll just bring up it to my tables, bill of materials, and we can snap that into the corner there, and it brings through our bill of materials. But I would like to be able to show exactly what each of these components actually is linked to. So which one is number 1, 2, 3, 4, 5, etc. To do that, I'm going to create some balloons. So again, I'll right click on my view and we'll auto balloon. I'm going to show all of my instances. Now, initially, I can choose to put them all at the top, bottom, left or right. I can show them in a square, or I can show them circular. So I'm able to balloon all of these. Now, let's say I'm going to go to the left-hand side here. I'll hit the tick, and that places all of these balloons on the left-hand side of the drawing sheet. Now, there's not really enough room on the left-hand side of the drawing sheet here, so I want to reposition some of these balloons. To do that, I'm going to use a really cool functionality called magnetic line. So magnetic line allows me to place lines down that I can then use to snap all of my balloons to. So for example, if I wanted to create some on the right-hand side here, I'll draw a line down here. Now I can grab any balloon and bring it over here and snap it to this magnetic line. Now notice, as I drag it onto the magnetic line, it is automatically spacing those balloons out for me. As I change the length of the balloon, they continue to be auto-spaced correctly. So, let's say we've got some more components over here. So I'm going to select the magnetic line again, and this time I want them to be on a little bit of an angle. I can now drag these components, or these balloons rather, onto this magnetic line here. And where I position it, it automatically repositions the rest of the balloons to match that. I can then move that magnetic line around to change the position of these balloons. I can even move the whole line if I want. I want that one onto here, maybe I want to snap it onto that line there. So we're able to very quickly, now this one over here, I want to change the settings so that it equally spaces these balloons here. Now when I bring this up and down a bit, it's starting to look a bit better, but some of these are crossed over, so we're able to reorder those so that they're not crossed over anymore. So that's looking pretty good. So the final step that I want to perform now is going to be to take this brand new assembly and bring it back into that boom assembly that we were working on before. So I'm going to come back to my boom assembly and we're going to insert our mount assembly into the boom assembly here. Now, I want to attach it such that it is centered with respect to here. So the way I'm going to do that is I'm going to grab this bottom edge here and attach it to this edge down here. There's the first one. I want another copy of it. So I'm just going to hold down Control, drag another copy out into space here. And this time, I'm going to grab the top edge and drag it onto this hole here. So that way the grease fitting port is on the outside for that one there. Lastly, I want to attach these two components using these faces here. So my pop-up toolbar here to apply that relation there, and another one between these two components here. So in about 30-35 minutes there, we've managed to create a part, create an assembly, create a drawing of the part, create a drawing of the assembly, and then mount those components back at the top level again. So what I'm going to do for the last 5 minutes or so is get you to ask questions. So if you want to ask me a question, you can just, if you want to type into the questions area there, and I'll endeavour to answer your questions. Yep, so there's a question there on showing movement between the parts. Because we're able to drag the components between them, we can drag those components through their range of motion in such a way that we can also look for things like interference detection, so we can have it stop if there's a collision between components and things like that. We can also look for interference both statically, so you can say right now in the position where the assembly is there any interference? and we can also drag the components through the range of motion to see if they collide as we drag those components. Any other questions, guys? Well, thank you very much for your time and your attendance. I know you said most of you will be giving up your lunchtime to take a look at this. I hope it's been very informative. There will be some feedback requested of you, probably just a quick survey or something like that sent through just to see both what you got out of this and also to see if there's any other areas of SolidWorks that you'd like to see a presentation on. So there's also been a question there from Scott about we're requesting a soft copy of this. Yes, in about a week or so, this should be available on the INTERCAD website along with all of our other recorded webinars. So thank you very much for your time, guys. And yeah, as I said, I hope you got a lot out of it.